How's it going, guys? Today in this video, we're going to be going over Module 15.2, Day 2, graphing logarithmic functions. So graphing logarithmic functions is going to be very similar to graphing exponential functions. Since they are inverses of each other, the graphs are going to behave very similarly. The only difference is the x's and the y's are going to flip. We talked about in the last video, or in the last lesson. So our general equation for the transform function of a logarithmic function is right here. F of x equals a times the log of base b of x minus h plus k. And our transformation rule is still going to be the same thing, x plus h, comma, ay plus k. And our two parent reference points right here of 1, 0 and b1, our transform reference points are going to be x plus 1, comma, k, and sorry, it shouldn't be x plus 1, it should be h plus 1. So h plus 1, comma, k, and b plus h, comma, a plus k. And for both these transform reference points, you don't actually have to have them memorized because they're both gotten by putting in our reference points, our parent reference points, into our transformation rule. So you don't actually have to have them memorized, because you just plug in the reference points into your transformation rule, and you'll get the same exact thing. All right? So anyway, our transform asymptote is going to be x equals h. Our asymptote is always going to be x equals h. And a couple more things I want to add on to this page right here is that for our purposes, since we're not dealing with B's, we're not dealing with horizontal reflection, our domain is going to be x is greater than h. No matter how we reflect it with A, if A is positive, A is negative, if we reflect it over the x-axis or not, our domain will always be on the right side of the asymptote. So in our purposes for our class, our domain is going to be x is greater than h. And then for the range, our range is always going to be all real numbers. So from negative infinity to positive infinity. For a logarithmic function, our range is negative infinity to positive infinity. And for a logarithmic function where we're not dealing with horizontal reflections, which we don't in this class, our domain is always going to be x is greater than h. So let's go ahead and do an example. On number 1, our a is 2, our b is going to be 10. We're not given a base with this log. If we're not given a base with the log, that's because it's the common logarithm is the common log. Or in other words, it's so common, we don't need to bother giving you the base because it's assumed to be 10. We don't give you a log with a base, the base is 10. So it means our b is 10, our h is negative 2, and our k is 4. Our transformations, instead of that, we're going to do our transformation rules. That's x plus h, so x minus 2, comma, ay plus k, so 2y plus 4. And you guys should know what A, B, H, and K do. Our A's are reflection over the x-axis, or our vertical stretches and compressions. Our B doesn't do anything for our transformations. Our H is our horizontal shifts left and right. And our K is our vertical shifts up and down. But anyway, our asymptote is always going to be x equals h. So we have x equals negative 2. And then for our two reference points, our first reference point comes from the parent reference point of 1, 0. We're going to plug that into our transformation rule to get negative 1, comma 4. And our second reference point, that comes from B1. Our B in this case is 10. So the point that we're plugging into our transformation rule to transform is 10, 1. And when we transform it, we get 8, comma 6. Our domain, for our purposes in our class, is always going to be x is greater than our h of negative 2, and our range is all real numbers, so from negative infinity to positive infinity. And if you wanted to rewrite the domain in interval notation, it's going to be negative 2 to infinity, just like that. So now we're going to graph our function. Our asymptote is x equals negative 2. So right there. And our 2 points of negative 1, positive 4, and 8, positive 6 will be just like that. And when we're graphing our function, we always go left to right. So we see that our function will look something like that. We go from left to right, so from the asymptote away from it, and that's what our function will look like. Now for number 2, I want you guys to pause the video and try that out on your own. And if you will pause the video, try it out on your own, and I'll put the answer up in a bit, and we'll go over it. All right, for number 2, this is what you should have gotten. Our A is 3, our B is E. The natural log is the same thing as the log base of E. So anytime you see an ln, that's a natural log. That's going to have a base of E, so our B is E. Our H is -4, our K is 2. So our transformation rule is x minus 4, comma 3y plus 2. Our asymptote is x equals -4. Our first reference point is 1, 0. That's going to transform into our actual reference point for our graph of -3, positive 2. And our second parent reference point is going to be B1, or in this case, E1, and that transforms into E minus 4, comma 5. Our E is approximately about 2.7. So 2.7 minus 4 is about -1.3. So the point we're plotting is approximately -1.3, comma 5. Our domain is always x is greater than h. So in this case, x is greater than -4. In interval notation, you'll see it like this, -4 to infinity. And our range is all real numbers, so from -infinity to positive infinity. And your graph of the function should have looked a little bit like what I have on the graph over there. It should look something like that. All right, now I want to do the same thing for number 4. Number 3 you can do on your own, but number 4 I want you guys to pause the video, try that out on your own, and we're going to go over it in a second. All right, so this is what you should have gone for number 4. Our A is -3, our H is 1, our B is 10. Since we're not given a base for this log, that means we can assume that's the common logarithm. It's so common we don't need to write out the base. So our base is 10, and our K is -4. Our transformation rule is going to be x plus h, so in this case x plus 1, then ay plus k, so -3 times y minus 4. Our two transformation points that we're going to, two parent transformation points that we're going to transform are 1, 0 and B1. 1, 0 turns into 2, -4. B1 is going to be the same thing as 10, 1 for this problem, and 10, 1 transforms into 11, -7. Our asymptote is right here, x equals 1. And if we plot our graph, it should look a little bit like that. Our A is negative, so we reflect it over the x-axis. And we can see we're still on the right side of the asymptote. So our domain is still x is greater than our h value. It doesn't matter if you reflect over the x-axis or if you reflect vertically. It doesn't change the domain. So our domain is still x is greater than h, and our range is still all real numbers. Anyway, guys, that's the video. It's not too long. It's very, very similar to graphing exponential, so it shouldn't be anything all too new. But if you're still having trouble with it, rewatch the video a couple more times, do a couple more problems, and hopefully this helped.